Hi, this is Miss Marion. This is Unit 2, Lesson 9. Go ahead and turn back to page 122 and go ahead and read the I can statement. Well, there's two of them. I can decide if two triangles are similar by looking at quotients of lengths of corresponding sides. I can find missing side lengths in a pair of similar triangles using quotients of side lengths. So these are things that we're doing for today. Go ahead and write a sentence about how you feel about it. And give yourself a number. Number 1, I don't really understand. 2, I kind of got it. 3, I did get it. But then 4, I can go ahead and teach it to my friend. Go ahead and write a sentence and go ahead and give yourself a number. Let's go ahead and turn to page 75. On page 75, 9.1, 2, 3, 4, and 4, 5, 6. What you're going to go ahead and do is you're going to answer the question. Triangle A has side lengths 2, 3, 4. Triangle B has side lengths 4, 5, 6. Is triangle A similar to triangle B? So go ahead and pause right now and answer that question, and then also give an explanation why. So let's go ahead and let's answer this question. And so are the two triangles similar? Well, that answer is no. Okay, these are no, not similar. And then let's look at it and let's see why. So to go from 2 to 4, remember we're kind of dealing with that scale factor kind of thing, and we're going to multiply by a number. So to go to 2 to 4, I can multiply by 2. So 2 times 2 equals 4. Let's try it with the other ones. So we're going to take 3, we're going to multiply it by 2. So is 3 times 2, 5. Well, no, that doesn't work. That should be 6. Let's try it with the last one. And so let's take 4, let's multiply it by 2. So is 4 times 2, 6? Well, no, that doesn't work either. That answer should be 8. So remember that we need to understand that triangles cannot be similar if you are not able to multiply every single side by that same scale factor. Remember, a couple lessons ago, we were doing that and combining things together as far as the different pictures. We had to look at those sides, and do we have a scale factor that we can multiply all the sides by to kind of make each other kind of thing. And this one, it didn't work. So are these triangles similar? No, they are not. So again, here are the triangles that we have. Again, you can kind of look at it. Here, the 4, and then we have 6. We have like 4, and then 5, 3, 6, and then 2 and 4. Do all of these work as far as having the scale factor, the same scale factor of 2? No, it doesn't work, and we just barely proved that. On the bottom part of 75 and actually going into 76, we are going to do an activity. It says your teacher will assign you one of the 3 columns in the second table. We're actually going to be doing the whole entire table. Unfortunately, we're not together as a group, and if we were, we would kind of work together. But right now, we need to kind of understand all of this. So we have triangle ABC is similar to the triangles DEF, GIH, JKL. So we're kind of looking at these 3. So we have all these triangles. The scale factors are the dilations that show. So we have our scale factor. We have 1, 2, 3, and then 1/2. And then we have triangle ABC. We have the length of the short side, length of the medium side, and then length of the long side. And then we're going to go ahead and find the sides of all of these with this scale factor. So grab your calculator, and we're going to go ahead and do that. So remember, the way that we are going to do that, we are going to take 4. So we're going to do DEF. So we're going to take 4. We're going to multiply it by 2. So 4 times 2 equals 8. Okay. Let's do the next one. So we have 5 multiplied by 2. So 5 times 2 is 10. And then let's do the last one. We have the 7. We have 7 times 2. Let's make that a little bit better. So 7 times 2 equals 14. Go ahead and fill in the rest of this table. And then we'll actually, so you want to pause it, fill in the rest of the table, and then I'll show you how to do the second table. Now, since you filled down that table, we're going to look at the second table also really quickly, and we're going to fill that one in also. Notice how we have the longest side divided by the shortest side, and this is triangle ABC. So they have the longest side was 7, divided by the shortest side, which is 4. And we're going to go ahead and find that decimal. So do 7 divided by 4, you're going to get 1.75. So once you filled in the top table, you need to fill in the bottom table. And you're going to do them for all of those. And go ahead and write those. This is actually on page 75, or sorry, on page 76 are your tables. Go ahead and fill those out, and then we'll see if we got the same answer. Here are the answers that you should have gotten both for the top table and also the bottom table. Now, it does say in your book to go and compare your results with your partner. Well, unfortunately, we don't have a partner. But what I want you to do is to look at number 2. It says to go ahead and fill in the bottom table, and it says, what do you notice about the quotient? Remember that quotient is a division. It's an answer to a division problem. So what do you notice about the answers pretty much in the second table? Go ahead and answer that question and put it underneath number 2 on page 76. So go ahead and pause right now and answer that question. All right, let's go ahead and talk about it. What did you notice? Well, one of the things I noticed is all of these are 1.75. So this scale factor is 1.75. All of this one, the scale factor is 1.4. They are all the same. And over here, our scale factor is 1.25. They are all the same. And the reason why we have this is because all 4 of those triangles, well, the bottom 3 of them are similar to triangle ABC. So let's go ahead and let's turn to page 78 and let's actually try this ourselves. So here we have triangles ABC, EFD, and GHI are all similar. The side lengths of the triangles all have the same units. Find the unknown side lengths. And so we can actually use the idea of a quotient or a fraction, going ahead and finding the different side lengths itself. So we are looking for E, D, and H. So also C. So let's go ahead and pause for a second. Let's go ahead and find all of those side lengths and figure out what those are. So pause at this time and answer that question. So the first one I'm going to go ahead and solve for is I'm going to solve for C. And the reason why is it kind of looks like these two kind of are in the kind of same area. So I'm going to do 12 over 5 and then over 4. Because remember, we're going to go ahead and put those in kind of a quotient or a fraction form. So we have 12 over 5 divided by 4 is going to equal, and then as you can kind of see, I have 6 over 5 and then I have C. So let's go 6 over 5 and then C, because we're looking for letter C, right? And remember, in 7th grade, we know that we can cross multiply and divide to go ahead and do that. So let's do 4 times 6 over 5. And we are going to get 4 and 4/5. We're going to do C times 12 over 5. So we have 12 over 5 C. And then remember, we can divide by the 12 over 5. Let's go ahead and put that in our calculator. Press enter, and we're going to get C is going to equal, I'm going to put it over here, C is going to equal 2. So this answer up here is 2. Now, let's go ahead and let's find H. We can go ahead and find that. And so, again, we're going to set up a fraction or like a quotient kind of thing, just like we did here. We're going to go ahead and set up the same thing. We're going to set it up for H. So I'm going to do 12 over 5 and 4 again. So we have, let's do red. So 12 over 5 over 4 equals, and notice how h goes with 4. So we're going to go h over 4. Again, we're going to go ahead and cross multiply and divide. So 4 times h is 4h. 12 over 5 times 4 is 9 3/5. Divided by 4. Okay, divided by 4. And make sure you simplify your answer all the way down. And so h, because 4 divided by 4 is 1. H is 2 and 2/5. This is also known as 12/5. So our h is going to be 12/5. And then we can also do the same thing with e and h. We can set up those fractions. And then if you've done e and h correctly, e should be 10. And h so also, or sorry, d should be 10. So I do want to point out, you can actually set up these fractions a little bit differently. This is just how I set them up. But notice how some people, if you might have noticed, you actually set up a little bit different, but you got the same answer. And so what we, again, when we have similar figures, similar triangles, we have to deal with triangles today, the side lengths, we can set them up as we kind of noticed, we can set them up as fractions and proportional relationships, or fractions that are equal to each other, and we can go ahead and find those missing sides. So remember, when we have similar triangles, our angles are the same, so the angles are congruent, but then the side lengths are pretty much fractions of each other, and they have a scale factor. So as you can notice on page 79, again, we have two triangles, right? And we have the side lengths, and then we can actually find that fraction as far as taking with the smaller, we can do the medium side divided by the shortest. On both of those, we can actually find that scale factor. How did they change? How did they make it bigger and smaller compared to each other? So again, if the angles are the same, exactly congruent in triangles, and then the side lengths can be proportional, they can have a scale factor that makes it bigger and smaller. Go ahead and turn back to page 122. Write yourself a sentence about today. I can decide if two triangles are similar by looking at the quotient of the lengths of corresponding sides. I can find that scale factor. And I can find missing side lengths in a pair of similar triangles using quotient of side lengths. So we can make that equal, those fractions equal to each other and find them. Write yourself a sentence. And then also make sure you give yourself a number. 1, I didn't get it. 2, I kind of got it. 3, I did get it. But then 4, I can actually teach it to my friend. Go ahead and write that on page 122. And then please make sure you go ahead and do the practice problems for today. And I hope you have a great day. Thanks. Bye.